Hello everyone and welcome to Unacademy classes. Today we are going to discuss important milling questions. Let me first check if the stream is working properly or not, because then I will be ready to go. It will take just a few seconds and I think I am live. So let's start the class. So again, hello everybody. Welcome to Unacademy classes. My name is Abhishek Mishra, and just like some of our previous classes that we were discussing, in this class also we will discuss important questions. So in today's class we will be specifically discussing milling questions. So that will be the main and only topic that I will be covering in this class. And milling is again a very important topic because, as you can see, questions um in the previous years, some questions have come from this topic. And again, this topic is not that hard. We just have to uh, know the correct formulas and all that. There is some theory also that you should be just well versed with. So let's, without further ado, let's just begin the class. And we will start the class as usual by, first of all, I will introduce myself to the students who are watching this for the first time. And also I will then give you an introduction of the Unacademy subscription and how it can benefit you, and how you can find me there. If you want to attend some more classes from me, then I am available there. I am also taking class there, so you are always just free to come there and attend the classes, and again learn from wherever you can get best education from, and just prepare in a manner that you are satisfied at the end. So let's begin. So about me, I have secured all India rank of 662 in GATE 2020, and I have completed my MTech in 2019 from IIT BHU Varanasi. I have got 2 years of mechanical engineering teaching experience, and some of my interests are photo editing, video editing, cricket, football, and games. All sorts of games I like. So Unacademy's app is free to download, so just download this app and just check out its features. Since this app is free to download, so you should at least check it out before just passing it. And I believe that you will find that this app has the features of this app will benefit you a lot, and you will also agree with that after using this app. So this app has all things covered. So name one thing which you require for your online preparation, and this app has it. So this app is a complete package for online preparation, and just download this and check out for yourself. And again, when you download this app, you can just follow me there at Unacademy, so that whenever I go live, you can get notification and you can attend my classes there. And it is always better to attend live classes, because in live classes we can interact a lot more, and especially in my classes I make sure that I am clearing all the doubts, and I always watch the comments, so that the engagement is there. The And you also feel very, you feel just very ease at my classes. And therefore live classes is the way to attend online classes, and you should always try to attend a live class. So let's now discuss about Unacademy subscription. So Unacademy subscription plan will give you this benefits: daily live classes. So live classes will be held daily, day in day out, and you can ask your doubts, answer polls. So basically the Unacademy's website or their app is providing the interface and the basic class layout and the features, which are far better than anything you have seen on YouTube and some other sites also. So why it is that? Because YouTube is general purpose video streaming site, but Unacademy specially made, tailor made for your online education, online preparation. and therefore the level of interaction that you can just have in an Unacademy's class, uh, in an Unacademy's website subscription class, it will be unmatched. And just you will find that you can find that the classes that you are attending there will be very similar or even more than the level of interaction than your offline traditional classes that used to happen. And again, you have to at least subscribe for 1 month and check out its feature and this live classes firsthand before just passing it on, because I believe that it is one of the best ways, or not one of the, it is the best way to study online. And live tests and quizzes are also there for you to evaluate your preparation. And again, you will be provided with detailed analysis, so this is a very good and nice feature to have, because you while you preparing for gate, you are not only expected to just give test and just move on. If you are preparing, if you want to prepare well, if you want to score good, then you have to analyze your performance. You have to see in which areas you are lacking, in which areas you are taking more time, where your mistakes are happening more, which silly mistakes you are doing. So this type of things you can just see and avoid by giving test. And structured courses are there. So when you are going to go to Unacademy's website or app for just online preparation, then you will see the courses there are arranged in a manner which is first of all in line with your syllabus, and they are also structured in such a manner that it creates a rhythm which is very important for your preparation. And unlimited access of contents will be there. So if you are going to subscribe to Unacademy, then not only you will be getting content from the day you have subscribed, but also the content which has already happened before your subscription date. So unlimited access, one subscription provides you all these benefits. So it is better that you just check out the Unacademy website and at least for 1 month just subscribe and start your preparation. And I will now provide you one code which will give you extra discount so that you can get the Unacademy subscription at least possible price. And there are top educators, so you will be having uh, your online preparation done by this top educators who are obviously very experienced in their respective field. And also these educators and me also, what we will do is we will not only give you just the theory and the syllabus, just complete the syllabus, we will try to give you information that will help you in scoring good marks. So we will give you tips and tricks. And I in my classes also like to analyze a question after we do that. And also after that we discuss what are the potential errors a student can make. And so that we are very well aware of these things, so that when final exam comes, we can score the as much as possible. So that is the main aim that Unacademy follows, or the teachers here follow. And there are multiple educators for a single subject also, so you will find that there is option for you to just select an educator which resonates with you most and just attend his or her class and just learn from them. And here is the new subscription prices. And as you can see, 1 month, 3 months, 6 months, 12, 18 and 24 months subscription prices are there shown. And these are the plans that you can just select. So if you want to save more, then 10% off code is ABHIMI. And this prices also include, the subscription plan also includes test series, which is again very important as I have discussed. And you can select uh, the payment option as no cost EMI, which is available on 6 months and above subscription plans. And the plans prices shown here are for a plus subscription type, which is basically classroom experience, where you will be studying along with other students. You all be attending a single class, and there you can discuss with the educator about your doubts, answer polls. So just like classroom, the plus subscription type is going to have classes. And these are the final discounted prices which you can only get if you just enter this 10% off code ABHIMI. And the code here, as you can see, is universal, so you can just apply this for not only gate examination for but for any other examination also. And this code ABHIMI is also uh, can be shared with other students and your friends, so that they can also avail the benefits, because multiple accounts can use this code and get this Unacademy subscription at least possible price. And if you are not sure that Unacademy is uh, worth your time or worth studying for, then you can always go for 1 month plan. And 5000 it is basically very reasonable price for the amount of content that Unacademy is offering. But if you want to save more and get this in least possible prices, then select at least 12 months plan, because 12, 18 and 24 months plan will provide you most amount of savings. So that is one thing that you can do. But if you are not sure that you should commit for that much longer, then always select for 1 month. And then just if you find it good, and if you find the Unacademy subscription resonating with you, and therefore you can then select the more months plan after just trying it out for 1 month. But make sure that you at least try for 1 month, because it will help you a lot. Iconic subscription prices are shown here, and again same code can be applied to get this subscription prices at least possible price after this 10% off code ABHIMI. And Iconic is for those who need personal coach, personal test series and things like that. Basically more assistance if you need, then go with Iconic. And if you are okay with classroom experience, then Plus is one of the better plans then. And Plus and Iconic are here with the benefits, and you can see that this code is applicable both for Plus and Iconic. And I am just pointing this code again and again, because this code, if you just keep entering this code, then you will find that your savings which you can make, you can easily lose that. So use this code, make saving, just subscribe to Unacademy and start your preparation, start giving test series, start attending my classes there. And just have the unlimited access option, so you can study according to your pace, according to your schedule. And therefore now we will going to start our today's class. So the first question for the day is, conventional or traditional machining methods include. So what among these methods is a conventional or traditional machining method? Milling, casting, electrical discharge machining, none of the others. So none of these. See, electrical discharge machining. So here you can just see that EDM, electrical discharge machining, is a non-traditional machining method. So that will not be the answer. It is non-conventional, non-traditional. And B is casting. It is again a traditional and conventional method, but it is a manufacturing method, not a machining method. In machining method, what we do is we remove material. So it is a method where material removal gives us desired shape and size object. But casting is not that. Casting is basically pouring of hot metal into a predefined cavity to get the required shape and size. And milling is a machining method, therefore in milling material will be removed, and it is also a traditional or conventional machining method. So the correct answer to this question will be A, milling. Why not casting? Because it is not a machining method, and the question is asking us for a traditional machining method, even though a traditional manufacturing method but not machining, therefore casting will not be the right answer here. And EDM, electrical discharge machining, is the machining method as the name suggests, but it is not a traditional method, it is a non-traditional method. So C will also not be the answer here, and D is the none of these, which is not the answer, because A is the one that is just agreeing with all the things that is being asked in the question. So answer will be A, milling. Which of the following statements are correct? So here four statements are given and we have to just select the statements or statement which is correct or which are correct. In down milling, the chip thickness is maximum at the start of cut and 0 at the end. In down milling, the thickness is 0 at the start of cut or maximum at the end of cut. In up milling, chip thickness maximum at start, 0 at end. And also in up milling, in the last option, it is given that chip thickness is 0 at start and maximum at the end. So in down milling, so what will be the correct answer here? Let me just inform you. In down milling, the chip thickness is max at the start of cut and 0 at the end. So A option is correct because that is how chip thickness varies in down milling, and we will discuss more about down milling and up milling just after I answer this question properly, and we will see what are the differences between them, what are the features that they provide, and things like that. So let's first answer this question. A option is correct, and also you will find in up milling the chip thickness is 0 at the start and maximum at the end of cut. So D is also correct. So this is a multiple answer correct question, and A and D are the correct answers here. So remember, down milling, chip maximum thickness at start, and in up milling, 0 thickness at start of cut. So now let's just discuss about the down milling and up milling. So let's see that. So peripheral mill cutter is classified as up milling, down milling. So up milling and down milling are the things, or are the just the types of a peripheral mill cutter. And let's now look into up milling first, then we will look into down milling. So let me just first of all draw the up milling figure. So up milling. So right now what we are discussing is up milling versus down milling, and let's just see what their differences are, and I will share a lot of nice information here. And here you can be, after just seeing what things I have discussed, you should just realize that you have a lot more information after we have completed this discussion about up milling and down milling. So this is a mill cutter, and here I am going to draw this figure in a manner that by looking at this figure only, you can answer a lot of questions about up milling and down milling. So first I am drawing about up milling and discussing about up milling. So this is maximum. So as I have just answered the question just before this, that is this question, in up milling, the last option which I selected as correct, it up milling, the chip thickness is 0 at the start and maximum at the end. And you can see in this figure also, the chip thickness is a minimum at the start, which is 0, and a maximum at the end. And here is the up milling cutter, and let's make this more properly. So this is the direction of the workpiece, and this will be the direction of your cutter, and as you can see, it is having an opposite direction as compared to your workpiece. So this is another thing that you have to remember, which might get asked in gate examination, that in which type of milling, up or down, the cutter, that is the tool, and the workpiece are having opposite direction. The answer to that will be up milling. And let's see if any other things here is left to draw or left to just discuss. So that will be it for the drawing. Now let's discuss the important points about up milling, which is a peripheral mill cutter or peripheral milling type. So first of all, peripheral mill cutter, let me just share another information here. This cutter is used in slab or plane milling. So this is used in slab or plane milling, and up milling is known as conventional milling. So let me share you information here, and you can just note it down in your copy if you are finding any of this info uh, just good for your revisions. So conventional milling is up milling, and direction of the cutter and the workpiece will be opposite. So let me just write it: cutter and workpiece direction is opposite. So this point right there, the second point, you have to remember this, because again objective type questions might get asked. And the next point is, to the chattering here is more as compared to down milling. Why? Because the cutter tends to lift the workpiece above the table. So this by seeing at the third point, you can just know that there will be chatter, because there will be lifting of this workpiece, therefore this chatter will occur there. And we will see that in down milling it is not the case, because down milling, as the name suggests, it will not lift, it will just push it towards the table. So that will again be a differentiating factor among these two types of milling. And chip thickness here varies, like T min from at the start to Tmax at the end. So let me just write it here also, that Tmin is equal to 0 at start, and Tmax is encountered at end. So this is for upmilling. And now we have another information I have that I would like to share is surface finish here is poor, and why it is poor I will give you the reason of that also. So let me first write surface finish is poor. Why? Because of chip recutting. So this informations, I don't think that you will find all this information in one place in any book or in any class, but I am providing here because I have collected this information over the years of my preparation and my teaching. So you are getting that much of work, years of work, because again this informations have to be found by going out of your just normal study content, because that is not that is not there. The first 4 points are always taught in the class, but surface finish is poor. Why it is poor? It is not usually concentrated, but when you are giving interviews and when you are just preparing for GATE information, you have to, if the theory is not that large, then you can just always try to remember the reasoning of the thing that you are studying. So if surface finish is poor, so why it is poor? Chip recutting. So it is always good if you do this. So chip recutting, because chip drops in front of cutter. So chip drops in front of cutter because, as you can see in upmilling, by looking at the figure also, it should be clear then that while cutting is going on, due to the nature of the motion of cutter and the workpiece, the chip will, after cutting, just drop in front of the cutter, and therefore it will be recut, and which will ultimately make the surface finish poor. And tool life is less. More power is required. So I hope you can understand why this points are there. The last points, basically what we have discussed here, will result into these things. And now we will discuss about down milling, up milling. A lot of things I have again uh, just given you here, and again you can also deduce from this information that up milling will be used for, or up milling is generally used for rough machining or rough surfaces. Why? This information that I have provided is having that why answer. So for rough surfaces, why for rough surfaces? Because surfaces finish is poor, and for rough surface, for rough machining, we first of all want the machining to be just happened, and therefore surface finish is not that good. If for a machining, then it can be selected for a rough machining but not for finish machining. So that will be the information for up milling. And from here also, that is cutter tends to lift the workpiece, you can deduce one thing, or you can just realize one thing, that clamping must be strong. So what is clamping? Clamping is required to just hold this workpiece still into the table, not to get, so that it not gets lifts, and as the cutter is tending to lift the workpiece, so the clamping must be strong and therefore that is one of the things that you can also just get to know after you have just learned about these things written in maroon color. So just for gate examination, what you have to do is to learn this theoretical section that I have just taught you two times. It should be enough if you just go through them two times. Not, I am not telling you to just remember word by word every detail. I am just telling you to go through them at least two times properly, and that will be it. Then you can after doing that you can just do your objective type questions, because again in the gate this type of questions will come with options, and you can always have that easiness of answering by looking at the option. So if you at least remember details here and understand what is the basic concept behind upmilling is, then you can attend this upmilling questions. So at least go through them twice so that you can remember. So let's see about downmilling. So let me add here another slide. So now let's discuss about down milling. So for down milling, first of all, remember that it is also known as climb milling. So down milling is also known as climb milling. And now let's draw the figure here. So again, like the previous figure only, we are having T max at the top and T min at the bottom. So that thing is similar for this down milling figure also, but now comes a different part. Here is your cutter, and here is how it is cutting the workpiece. And as you can see, this cutter is having its doing the cutting like the first, at the start of cut, maximum chip thickness is going to get cut. And I should draw I think I should draw it more appropriately by making this cutter uh, teeth coming in contact with the maximum thickness. So let's draw it like this. So as you can see, the first at the start of cut, maximum chip thickness is being cut, and as the cutting operation is moving towards the end, the minimum chip thickness is going to get observed. So maximum at the start, minimum at the end, so that's how this is working on. So again, one more thing you can notice here, and which I am going to draw it like unlike the up milling, where the tool and the workpiece, the cutter and the workpiece, were moving in opposite direction, here they will be moving, cutter and the tool will be moving in same direction. So as you can see, in same direction their motion is occurring. In what type of milling? In down milling. And therefore another thing, you can just I can just write it here like same direction. That should be clear what I'm trying to just mention here. And let's see what are the other things that we can just learn from here. So same direction is the first thing, and I'm not going to repeat that, and that should be clear. Cutter tends to push the workpiece. What was happening, and I should write here one more line. So what was happening in up milling? As you can see in this point, let me just highlight it. So this point right here, cutter tends to lift the, I think I should select a lighter one. So cutter tends to lift the workpiece above the table. So clamping must be strong due to that. So that is not the case in down milling, because as you can see it is pushing the workpiece towards the table, and therefore what we can say here is this is helping, or this helps reduce chatter. So this helps reduce chatter, and therefore it is a nice thing to have. So here we don't require, due to that we don't require that much of strong clamping. And surface finish is better because again their surface finish was not better, not good, because of chip recutting, and here it is better due to the fact that less chip recutting. So that is the only thing that you have to remember here, that less chip recutting is causing the surface finish to be better. So what is chip recutting? I have discussed in the up milling section. It was basically chips was dropping in front of the cutter, and therefore it gets cut again, and that was causing the surface finish to be poor in up milling. But that is not the case in down milling, so surface finish will be better and tool life will be high. This can be understood again from the things that we have discussed. And one more thing that you have to just remember here, one important point which can be asked as a objective type question. So just note it down somewhere in your copy, so that if this type of question, if this question comes, you can know the right answer to this question. So down milling, it reduces work hardening. So if you are doing down milling, then the work hardening will not be that much in your workpiece after the job is done, after the operation is done, as compared to up milling. So if you compare them both, then you will find that down milling is reducing the work hardening. So that is only thing that you have to remember for the work hardening, in which it can ask question get can get asked like this: in which machining, down milling or up milling, the work hardening is reduced. So your answer should be down milling. That's it. Nothing more can be asked from this concept, and you should just remember this as an objective type question. And therefore, that are the things that we discussed about up milling and down milling. So again, as you can see, we discussed a lot of things for this two types of peripheral milling operations. And you just have to again go through this at least two times, so that you can remember them. And no need to just learn them word by word. Just be aware of what these things are saying. And one of the better ways to be aware of them is to just look at the figure, and just you can draw this figure in your short notes copy. And while you are attending a class, for example, let's say if you are attending my class, then try to make a copy which is specifically dedicated to my class. And there you can write the concepts in as short form as possible. Don't write everything that I'm teaching, so that you can just revise all the concepts that I have taught in one place. And that way you will also find that you are having new things to learn. And don't just write everything in one place. Like, don't just write everything that you have to write in your manufacturing notes copy, because there you will find that you will be finding yourself overwhelmed when you are going to revise. So just make different things, so that you can open one thing and just have all the revisions done of that thing. So make things in short burst, so that I think it will be benefit for you, than just writing everything down at one place and be overwhelmed when you go to study them. So again, that will be the all the informations that I wanted to share about up milling and down milling. And now let's move forward and do the question here. So here we have a numerical question, and in this question it is given that it is given that a mild steel block of width 40 mm is being milled using a straight slab cutter 40 not 40 70 mm diameter with 30 teeth. If the cutter rotates at 40 rpm and depth of cut is 2 millimeters, determine the value of maximum uncut chip thickness when the table feed is 20 mm per minute. So we have to just determine the maximum uncut chip thickness value, and table feed is given as 20 mm per minute. So let's see what we can do to get the answer. So this question is asking us for a very simple calculation, and the maximum uncut chip thickness value will be twice. And here you will find yourself at the bottom fm under root, or I think I have written one thing wrong. It is fm at the top. Sorry, what I am doing, I am writing it wrong. It is twice Just wait a second. I think this must be the correct formula. Let me check the units. So yes, this is. So I somehow got the formula wrong. So let's just continue our discussion. So what this is the formula to calculate the maximum chip thickness, and again maximum chip thickness occurs is same for both down milling and up milling, and this D is the depth of cut and this capital D is the diameter of the cutter. So twice is the thing that you have to remember here. Don't just forget to uh, just multiply this with 2, because if you do that then you will be finding average. If you don't do that then you will finding the value of average chip thickness. And what will be the answer here? It will be 2 into fm. So fm is in per minute. So let us see if fm is given in the question or not. So that is not given in the question. No, that is given in the question at the last part. So we will write 20 here, and n is given as 40, and z is the number of teeth which a cutter has, not the number of teeth in contact. And here c number of teeth is 30. So that is the number of teeth the milling cutter has, and the depth of cut is simply 2 again given in the question, and the diameter is 70. So what will be the answer here? It will be, so it is coming out very less value, but that will be the correct answer. So let's write that 0.0056 mm. So this is the answer that is coming for this maximum chip thickness. And again, what will be the average chip thickness, which is not asked by the way in the question, but remember, minimum chip thickness, to calculate it you don't have to do any calculation because it is always 0 when this milling is occurring. And why we have discussed that in here, you can see how it is becoming 0, the minimum chip thickness. So average will be the sum of this 2 divided by 2. So average chip thickness will be simply maximum chip thickness divided by 2. So it will be 0.0028, which is by the way not asked in this question, but we still did that. And in one of the gate exams, I think in 19 or 18, it was asked that in the formula, or in the formula to calculate fm, that is this table feed in per minute. The formula to calculate fm, by the way, is this. It is ft, that is feet per tooth, number of teeth, into n, which is the rpm. So n is the rpm of the cutter rotation. So here the zt, it was two options were given for this type of question, and it was given that the zt is it either number of teeth in the cutter or number of teeth in contact with the workpiece. So the correct answer will be zt is number of teeth in the cutter, and you can see in this figure that zt value is given as 30. So that will be, let me write here t also, that will be the number of teeth in cutter, not number of teeth in contact. So that's why I am telling you to analyze a question after you have just solved it, so you can be aware of these things if some of this type of question get asked. So like in a lot of gate exams, a question has been asked, and I have also done this question in my class. Then what is the value, general value of n in the power law of strain hardening? So again, that you can do, that you can just give the answer when you, if you have seen that n value whenever you do a numerical properly. So just try to look at data, what they represents, how their range are, and you will find that it is not that much uh, of a work. You just have to do a question and just have to see what the information is given. Don't try to remember, then just have a look. I'm telling you to just have a look and just take away some information which you are finding just worth remembering. So for this question, that will be it. We have discussed a lot of things here apart from calculating the maximum uncut chip thickness. So let's move forward. So the next question here is a face milling operation question, and in this question it is given to us that we have to use this face milling to machine 5 mm from the top surface of a rectangular piece of aluminium. Length and width of that workpiece is given. Cutter has 4 teeth, and it is 4 teeth is cemented carbide inserts, and 150 mm in diameter. The cutter diameter is 150 mm. The cutting conditions are velocity 3 meter per second, feed 0.27 mm per tooth, and depth of cut is 5. So the metal removal rate during cutting is asked. So in the first line of the question, what we can just see is, so we have to calculate MRR first of all. And MRR formula for milling is quite different, we will see. And again, if you are solving this in home, you have ample time to get the answer, because I will be first of all going through this question and discussing about a few things there. So that time you can utilize by for doing this solution, and also you can listen the things that I am telling but while you are doing so. So a face milling operation is used to machine 5 mm from the top surface of a rectangular piece of aluminium. So the first line, let's see what it is saying. A face milling operation is used to machine 5 mm from top of the surface. So this line 5 mm from top of the surface is stating just that the depth of cut is 5 mm, and that is the amount of material that will be removed, depth of material that will be removed after cutter has gone through that depth. And a rectangular piece of aluminium workpiece is given, length and width of that is given. Cutter is having 4 teeth, and cemented carbide inserts are the ones that are used, and cutter diameter is simply given. And let's calculate now F material removal rate here. So let me just connect my laptop's charger. So where were we? We were discussing about the MRR calculation, the material removal rate calculation. So for milling operation, material removal rate is calculated like this. It is width of the workpiece into depth of cut into the milling feed, or the feed in mm per minute. So axial speed, you can also say this. So this will be in mm per minute, and this too will be in mm, and you will find therefore your answer in mm cube per minute. And again, we don't have that fm given in the question to us, but we have the data to calculate that. So first of all, we will do this calculation of fm. So this will be ft zt into n, and ft is given, feet per tooth is given as 0.27, number of teeth is given as 4, but n we have to calculate, and to calculate n we will use this, and here d should be in meter so that n will get in rpm. So the velocity here is 3. So let's do the calculation and get the answer. Diameter here is given as 150. So n is coming out to be 6.36 rpm, and fm will be 6.87, and it will be in mm per minute. So for material removal rate now, I will write it with a different color and give the answer here only. So for material removal rate now, you will find width which is 100 into depth which is 5 into fm which is 6.87. So this will be obtained as 343 7.75 mm cube per let's see if we can write it here. So we have to write it somewhere else. So that will be the answer, that will be the material removal rate. I am writing this value here also for you to just match, and unit is in mm cube per minute. So again, this question you get to know that the material removal rate here calculation is obtained after you are using this different formula, that is width into depth of cut into fm, which is nothing but the mm cube per minute, or not in mm cube per minute, mm per minute. So now it is a good time that we again revise what are the different formulas of material removal rate is, and therefore we can remember them, and let's see what we can just look into here, that I'm going to now discuss about the different material removal rate formulas. So for that, first of all, I would need a new page. So material removal rate is having different formulas. First of all, for turning, this formula is F D V into 1000. Why this 1000 came? This 1000 came due to this fact that we are putting V in meter per minute there, and this is for turning specifically. You can ask this in other, but it is more suitable that you ask the formulas for different formulas for different processes. Shaping is F D L N, where L is the length of the workpiece. And again it will be having the units mm cube per minute. And we have drilling, which is area of cut into Fn, or we can write it like this for drilling also and for general also. So let's remove the drilling here. So this can be generally seen for other formulas also, other operations also. So this is area of cut in mm square, and this is in mm per minute. So this will be in mm cube per minute, and this same can be used, the same formula, to get the not turning, milling material removal rate. So milling material removal rate is width into depth, which is basically the area of cut, into Fm, which is the feed in mm per minute. And again the unit will be mm cube per minute of this. And material removal rate can also be written if the area, if a circular cross section area of cut is getting removed, so it will be pi d. So this can be also written in, we can write material removal rate formula like this for turning also, where we are getting initial and final diameter after cutting, and initial is larger, so it will be like this into Fn. So again area of cut there. So this is another formula of material removal rate for the turning operation. Again their diameter is getting reduced, so this can be used to get the answer. So these are the formulas, and one more formula is there that I am going to just here provide to you. It is MRR is equal to power divided by specific energy. The power is having unit joule per second, that is watt. Specific energy is joule per mm cube. So you are going to get answer in mm cube per second, which will be the material removal rate. Another formula for you to just remember. So these are the formulas. Let me see if I have another formula somewhere written in my notes, so that I can provide you that also. And again write it down in your copy. Write down every formulas of material removal rate in your copy in one place, so that you can just have a look at them and be aware of which formula you have to use to get correct answer for a process. So that are the material removal rate formula for conventional machining processes. And I have here shown you 6 formulas which you should be aware of, and therefore write it down in your copy, then we will move on after a minute. So after a minute we will be moving on, and I will give you that time to write down the formulas. So let's continue our discussion, but we have a student asking a question. So Banu Ranjan, yes, my lectures, I am taking my lectures in English only, and the reason I am doing that because we are uh, learning all the theory or all the discussions we are doing. The technical sections are English only for GATE examination, and I want my classes to be such that a lot of students can watch, and English is a language which all of us here can understand if you are preparing for GATE examination. And so I will be taking my classes in English, but I will be taking it in a simple, not complicated English. I will be just discussing a relaxing manner, in calm manner, but in English only. So you can attend my classes and be rest assured that I will be taking entire class in English. Yes, that is the reason that I wanted to take my class in English, because again, we are having a lot of different languages all over India, and it is good that we can study in a common language, which is in what language which we are going to answer the GATE question paper also. So that is fine. And also, you can find me at Unacademy's website. I will be taking classes from tomorrow, so you can just not from tomorrow, from 5th December, that is day after tomorrow. So you can just follow me there, and let me just give you the link so that you can follow me there and attend my classes there, because I am going to do all the important questions there, also do some exclusive content there. So if you are finding my class okay to understand and helpful, then you can come there and just attend my class. And there also a lot of tools are there for you to interact. So if you want, then you can come. So let's now move forward and do the question here, but let me provide you the link first. So this right here is the link, and again, if you want to follow me, and you can do that and attend the classes there. Let me just erase this thing. So that's it, after a lot of difficulty. So Banu Ranjan, I will be covering metrology also, additive and lean manufacturing. So first of all, I will be covering metrology, and I have also covered metrology questions in a lot of my classes. You can go and rewatch them in the Unacademy's website. You can just follow me. Here is the link. And if you are following me, then what will happen is that whenever I go live, then if you have downloaded the Unacademy's app, then you can see that the notification whenever I go live. So that will be quite helpful if you want to attend the classes live. And I recommend you to attend classes live only, because there we can discuss this type of have this type of discussions where we can where you can ask the doubts and I can clear them. There are a lot of other students also who attend my classes there. So just make sure that you are visiting this link and following me there. And I will be covering metrology some questions in my classes. I will be taking a class which is specifically dedicated to that metrology questions, but we will be mainly focusing on metrology discussion by doing the important questions, and we will at the class we will discuss some important tricks also related to that. So again, follow me there so you don't miss the classes, and make sure that you revisit my previous classes also, because I have done a lot of important questions in my previous classes related to all of the manufacturing topics, not only metrology and machining. And we have discussed there a lot of tips, tricks, potential errors a student can make. We have analyzed the questions after doing that. So again, you can find all that in the link that I am providing you here. Just visit the link and follow me there so that you can get notified. Now we will move forward and continue our discussion. So here is the next question again for milling. So this question is asking us that a straight spur gear of 35 teeth needs to be cut on a milling machine with the help of indexing head. The number of rotations to be provided at the index crank for the purpose of indexing is nearest to. So we have to find the number of rotations. So here it is given that a straight spur gear of 35 teeth need to be cut. So we will have a gear blank first, that is a cylindrical disc like object first, and in this we have to cut 35 teeth with the help of this arrangement. So for milling you must have studied about indexing, and in indexing there are two types. So what is the answer first of all? So if you are watching live, what will be the answer to this question? It is not that much of a difficult question that here you can just answer it. So you have to simply give me the number of rotations, and the options are also provided to you. So I think that will be, I've given ample time now, and let me now give you this answer. So it will be 40n, and here the answer will be 40 by 35. And how? Let's discuss this. First, we have taken this 40n from the simple or plain indexing. Why we have taken 40 divided by n? Because there we use bevel gears, and which is having a gear ratio 40:1. Means to complete one revolution of workpiece, the crank needs to have 40 revolution. And here we are provided that we have to make 35 teeth. Therefore crank needs to be moving 40 divided by n to do the job. So what is I have just said is 40 revolution of index crank will be equal to one revolution of workpiece. So index crank revolution will be 40 by 35 for 1 by 35 revolution of workpiece. And why we have to calculate 40 by 35 here? Because we have to manufacture 35 teeth. We have to cut 35 teeth. So for that, index crank revolution needs to be this much to cut them. And now we will do the next question. In this question, it is asked that if a slab milling cutter is having helical teeth instead of a straight cutting teeth, then what will be the correct answer here. The options are given, and again I expect you to provide the answer, and then we will discuss that what is the advantage of providing helical teeth instead of straight cutting teeth. And it can be very simple because you have learned this same concept in your spur gears also, where we are having a helical teeth and what benefits they are just giving. So the options are: the cost of cutter would be less for helical teeth, the vibration arising out of cutting would be less for helical teeth, the cutter with helical teeth can only be used in down milling, and D is none of these. So the correct option to this question is helical teeth provides us with less vibration due to gradual engagement or due to gradual just contact. And when the straight cutting teeth comes, yes, B will be the correct answer. So Banu Ranjan, that is the right answer here. And I think you have also studied this concept in your theory of machines. Let me just give the answer correctly. So B is the correct answer. And why it should be very much clear to you, because if your teeth is having this straight instead of helical, then the first of all the length here the teeth will come in contact at the same time, the whole length of the teeth, but here the whole length of the teeth will not come in contact, it will come in contact gradually. Therefore by this logic you can understand that the vibration will be less. So there is nothing more that we can discuss here but this simple thing, that gradual engagement is making this less vibration. And next we have this numerical question, and this is a lengthy question, but the answer of this, so indexing concept is nothing of uh, that much you have to study it in deep. You have to just know the basic things, and I will teach you the indexing concept in this class only after we have gone through these questions. So let us see, this is the last question of the day, and after that I will give you indexing concept, all the concept that you should know. So I don't recommend you to just go that much deep for indexing for gate examination because it is not worth it. And again, you can always visit the NPTEL websites that are far better than any of the books, because books will provide you a lot of information that you don't require for gate preparation, and I will not recommend, because right now your main aim should be to score good marks and to study such that you can score them. So if you are just learning theory and theory which is not going to get asked in gate examination, don't do that. Do that some other time, but right now focus on the things which can help you score good marks. So visit NPTEL if you need more information about this indexing, but in this class I will try to provide the information that will be sufficient for your gate exam. So let's do this question. 50 flat pieces 1 mm width, initial dimensions given are to be milled, final dimensions are given, and end milling cutter is getting used. If the cutter of diameter 25 mm has 10 teeth and rotates at 100 rpm, then we have to find first of all the maximum uncut chip thickness, and after that we have to find the material removal rate. So I expect Banu Ranjan to answer this both questions, and let me just add a slide here so that I can solve in that. So this is the question. What we have to find? We have to find first of all the maximum uncut chip thickness, and after that we have to find the material removal rate, and I have provided the material removal rate a lot of formulas for you to just go through and use it and find the answer, and it will be in mm cube per minute, and it will be in mm. So I am giving you 2 minutes to solve both part of the question, and after that I will provide you the solution of it, and we will discuss some other things that is there to discuss in this question. So I will be back after 2 minutes. So that is the that should be it, and I hope you have answered the question. And what is the answer given by Banuranjan? It is uncut chip thickness is having the value as 0.0089. So that is, I think, the correct answer. Let us see, and what will be the material removal rate there. Also calculate material removal rate. So maximum chip thickness is obtained by using this formula, and the answer is correct given by material removal rate is coming as 50 mm cube. So let's see if that is the correct answer or not. What formula you have used, Manuranjan, to get this? If the formula is short, you can answer that in the comment section so that I can also know what the way you are using and if it is correct or not. Fm is given as 10 in mm per minute, and n is given as 100, and number of teeth is given as 10. Depth of cut is, yes, that formula I know that it will be the same formula, but what formula you use to calculate material removal rate? Yes, that is the correct formula also. So let's see what will be the answer of both. So here, what will be the depth of cut? It will be, so 1, and then we will have to calculate this 25 mm diameter. So the answer is coming out as, So is the depth of cut given different? Let me go through this question. So here it is given 1 mm, so that will be the depth of cut only. So where it is, let me read through question one more time. I think I must have missed it. So yes, it is, I have written here, I think mm here, but it should be, here I have written meter, so that got me confused. So it should be 5, this difference. So this, I think you should correct this also. That should be in different units written here. So it should be 5. And where that 5 came from, apologies for the mistake, it came from 30 minus 25. That is the initial minus final. So the answer will be, so it is coming out exactly what we have discussed in mm, and the average thickness will be half of this because we have a minimum chip thickness as 0, so average will be sum of that divided by 2, and material removal rate will be width into depth into fm. So this will be, width is given as 1 mm, depth is given as 5, we have calculated that, and fm is given as, so that should be the answer, 50 mm cube per minute. So now I will share with you the things that are required to do the indexing questions properly, and then we will end this class. So let's do that. So let me first of all add a slide here. So first of all, there are two types of indexing: direct indexing and simple indexing, that we have to just focus. For direct indexing, you have to remember that index crank revolution. So this is, first of all, I am sharing you the thing that is you need to be remembering for your numericals. So for numericals, remember index crank revolution for direct indexing is 24 divided by n, and for simple indexing it is 40 divided by n. Now let's discuss what direct indexing is and what simple indexing is, and why we are doing this, and what it is meant by these things. So direct indexing. So in indexing, what happens, for example, if you having this blank from which you need to make, let me draw this properly here, or let me just open. So here now we can draw properly the things that we need to discuss. So direct indexing. So if this is your workpiece, that is if this is the gear blank, and you need to cut a given number of teeth in this blank. So you are going to divide this, first of all, to do the job you are going to divide this workpiece into certain number of division. And if for example you have divided this into uh, 6 divisions, so 6 parts you have divided this into, so let us divide this into 6 parts, or 4 parts only, let us divide this into 4 parts only. So now you have a index crank, and you have your workpiece, and you are now required to move your milling cutter in such a way that it covers this fraction of distance. And this index crank will help you do that, because your workpiece is now divided into this 4 divisions, and you need to just uh, make this 4 divisions, or 1 division or 2 division or 3 division, according to your just process. And you want a system which gives you this fraction of divisions, and that system is this index crank. And in direct indexing I taught you that 24 by n is the index crank revolution. So this much index crank will rotate for 1 by n revolution of workpiece. And from here you can say that for 24 index crank rotations you will get 1 complete revolution of workpiece. So you have your workpiece, and if you want 1 complete revolution of workpiece, for direct indexing you have to make your index crank rotate 24 times. But if you want only a fraction of workpiece revolution, then you will also need less than the 24 revolutions of index crank. Therefore 24 by n, if n is 1, then it will be 24 revolution of workpiece, and if n is for say 6 or 4, then your index crank needs to be rotated 6 times to get this 1 by 4 revolution of workpiece. So how much divisions now your workpiece will be divided into? 4. So to cover this distance only, 6 revolutions will be needed. To cover this distance from here to here, you will need 12 revolutions of index crank, and here 18, and for complete you will need 24. So Banu Ranjan, I hope now you have understood why we are providing this indexing, why we are making use of this indexing, because we want to cover fraction of the workpiece revolution. If we only require to cover whole workpiece revolution, then we don't need this system. But since we are needing to cover only a fraction of revolution, therefore to do that this index crank is needed. And if you have simple indexing, then there the gear ratios are 40:1. So what this means is that for 40 index, let me write it properly here, for 40 index crank revolution, 1 workpiece revolution will be completed. So if you want, let us write, if you want 10 divisions in workpiece, then for 1 division, then to cover 1 division, provide me the answer, how much index crank should be rotated, how much revolutions. So Bhanuranjan, what will be the answer? If we have a workpiece and if we want to just make that 10 divisions in the workpiece, so if we want to make this, yes, that will be the answer. So if we want to make this 10 divisions in workpiece and to cover this one division only, index crank we will have to have 4 revolutions, and for 2 it will have to 8, and for 1 complete it will have to 40 if simple indexing is followed. So I think the main concept behind indexing should be clear to you. Now we will discuss some small details which we should know, and then this will be it for our indexing discussion. So first of all, for direct indexing, so I will cover this in more detail since I don't have the slide prepared before the discussion, therefore I have to just write it down quickly. So direct indexing, we will just see here that the gear ratio is 24:1, and here bevel gears are used. So remember this little information so that when objective type questions comes, you can answer that. And for simple indexing, let me write it here so that my video feed don't block it. For simple indexing, we have 40:1 ratio, and our gears are worm gears. Okay, so that will be for simple indexing, and that will be for direct indexing. Another thing that you can remember, and I think that will be, let us do one question that I have with me right now. So if you have this 34 divisions to be done in workpiece, then what will be for simple indexing, what will be the index crank rotation? It will be 40/34, but we have to simplify this. And how we can simplify this, let me tell you. Because when we do indexing, we have an index plate, and that index plate is looking something like that. Let me just see if I have a image of that. So I don't think the image is still with me, so let me draw it. So you have your index plate like this, and in the plate you have this holes which are standard values. So index crank revolution, if is coming in this 40/34, that is in some fraction, that you have to convert this into a simplest form possible so that you can make use of that. And what you can do here is, I hope you can understand how this 34:16 comes, because if you multiply 34 with 1 and add 6, you can find this value. This fraction could be converted into this form, and now we can just simplify this more by just dividing this 6 and 34, and it will come out to be not into should not be there, it should be come out to be. And we are doing this thing because we want the least possible digits here, because this index plate is having holes in standard forms 20, 18, 16, and out of this 16, what this means is that we have to first of all have one complete revolution, then we have to do this 3/17th revolution to get our required to cover our required division. So that will be the answer, and I think that will be it for the information that you need for your gate preparation. But I will cover this more properly when I have all the required figures and questions with me. Right now I don't think I have the required question, and just one thing, let me do it by removing this here. So to end this class, I would just like to tell you to remember that 24 is to n is the index crank revolution for direct indexing, and 40 by n is the index crank revolution for simple indexing. Okay, and always remember that for direct indexing, 24 revolutions of uh, index crank will be occurring for one revolution of workpiece. So by this way you can properly decode what the question is asking and properly follow the question. So that will be it, and again let me just give you one last information about the classes. So if you want to attend the class of mine on Unacademy's website, there I take do important classes, and so you can subscribe to this channel Banu Ranjan. Today's class I think I should have explained to you indexing a little bit more properly, but since I didn't have the required slides with me, therefore I will try to cover that in my Unacademy's class, and I will be starting the taking classes from 5th, and you can just visit Unacademy, use this code and attend my classes there. And the code you can just write it down in your copy, and again you can also come to tomorrow 2 p.m. I will be taking live class, and tomorrow's topic is grinding. So if you want to attend that class, you can do that also. And again, if you found this class helpful and engaging and questions proper, then hit the like button, and that will be it for today's class. Subscribe and hit the bell icon so that when an educator comes live, you can get notified about that, so you can attend his or her class live. And this is the code for you to get 10% off on Unacademy. So that will be it for today's class. Thank you to Banu Ranjan for joining us and having a very nice discussion. So that's it for today's class. Thank you for watching. Best of luck for your preparation. Take care and stay safe.